Hello and welcome everyone to this 24 Hours of PaaS Summit Preview 2019. We're excited you could join us today for Ike Ellis' session, Azure Databricks is easier than you think. This 24 Hours of PaaS consists of 24 consecutive live webinars delivered by expert speakers from the PaaS community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when these become available. My name is Reyes Khan, and I'm a DBA working out of Edmonton, Canada, and I'll be your moderator for this session. I have a few introductory slides before I hand over the reins to Ike. If you require technical assistance, if you require technical assistance, please type your request into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to Ike. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session, which will pop up after the webinar ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete this. Our next PaaS Marathon event is focused on career development and will take place on October 10th. Watch your inbox for an email when registration opens. Also, PaaS Summit 2019 will be happening on November 5th in Seattle, Washington. Head over to PaaSSummit.com and register today. This 24 Hours of PaaS session is presented by Ike Ellis. Ike is a senior data architect and partner for Crafting Bytes. He's been a Microsoft Data Platform MVP since 2011. He co-authored the book Developing Azure Solutions, now in its second edition. He's also presenting a session at the PaaS Precon titled Move a Successful Legacy On-Premise OLTP SQL Server Database to Azure, which is selling out very quickly. Please feel free to register for the session before it's sold out. And without further ado, here's Ike with Azure Databricks is easier than you think.
Hey guys, this is Ike. I'm so grateful that you guys decided to join us. I think that's an amazing sacrifice sometimes. I know in my time zone it's Tuesday evening. You could be with your families, but instead you're learning. That's awesome. So the goal of this session is to make Azure, Databricks, and Spark accessible. That's what we want to do. Is just like, this is not that difficult. You can do this. And if you're like an SSIS author, or you have been doing data analytics code in Transact SQL, and you think something like Azure, Databricks, or Spark is really complicated, or there's the learning curve is just way too steep. The goal of this session is to just calm your nerves a little bit, make it easier to understand what's going on, and talk to you about the main features of Spark and Databricks so that hang on one second, guys. I'm sorry. My dog has decided that now is the time to be rowdy. There you go. All right. So the goal is just to make it so that you're willing to experiment with this and able to start playing around with it and goofing around with it. Okay, so what is Apache Spark? Apache Spark is an open source project that has about, I think right now it's about 400 current contributors across several companies. The main company that contributes to Apache Spark is Databricks, and that company is the main distributor of a commercial version of Spark. So it's pretty similar to like how Linux has several different distributions like Red Hat, but in this case, Spark is the open source project, and the only distributor is Databricks. So Spark is a way of doing multi-processing applications that are spread over multiple nodes, and it creates a library that is easy to use and very easy to get to some type of parallelization plumbing that so you don't have to write all that code. So the idea behind Spark is that we can have data spread across multiple machines that have shared memory, so that memory across multiple nodes are all usable in one instance without changing your code. In fact, probably the easiest way to explain this is if you were to write a C# application. I'm just going to go to like Paint or something, open up Paint, right? So if you were to write a C# application here, and you wanted that application to run on multiple processors. So I'm just gonna make that a little bit bigger. Sorry about the screen size, right? And so you have a bunch of different CPUs here, right? And so your goal was that you're gonna parallelize that code across all these CPUs, right? Well, in C#, you would have to write a whole bunch of multi-threading code. You would have to handwrite that. And the complexity of having this parallelized in C# is that it would be very difficult to take a working application and write the code that is necessary to go down one node and then another node and then another node. And then you would have to then somehow on the other end reassemble all that code, the results of these answers all in one place, right? So in C#, parallelizing things is an active thing on behalf of the developer. The developer has to write a whole bunch of stuff that is necessary to make that happen, right? And so the idea behind Spark is that we don't need to write anything to make that happen. In fact, the code doesn't need to change at all, right? And just as a kind of a beginning thing to show you, this is Apache Databricks, right? This is one line of code where what I'm doing is I am reading a CSV, and I'm reading that CSV into memory, and then I'm just going to show you that CSV, okay? So right away, I'm just going to run this code. This is Python right here, and it's going to read this file, and it's going to show you the results of reading that file. And it takes a second, but it's typically not this slow. I don't know why it's taking a long time here. This is usually like 1 second here. My cluster's on, right? Yep, cluster's on. Okay, go. It figures that this is going to take a while, considering I just ran this thing right before the demo started, and it was immediate. So I don't know why this is taking a while right now. That's crazy. I've never seen it take this long. Let me see if I've got it in a different workspace. Oh, there it is. Perfect. Okay. I don't know why that took so long. Okay. So this code, you don't know whether or not this code was executed across one node or 20 nodes. You don't know that, right? And actually, I can change the number of nodes that were used to execute this code by just changing the cluster that I've attached to. So this cluster here says that I'm running on 8 cores and it's just one node. I could have a cluster that was 4 nodes, and in this drop-down list, if I just grabbed a different cluster and I ran the code again, and let's try to see if it'll run again faster this time. There. See how fast that was? That's what I expected the first time, right? So my point is that the degree of parallelizing code is disconnected from the Spark developer. So the person who's writing in Spark doesn't have to worry about how many nodes this thing's going to run across. They really don't have to even think about it. They can write the same code and they can run it over 1 node or 5 nodes or 100 nodes or whatever they want. And the code itself doesn't typically have to change. I say typically because, of course, there's always edge cases where you may want to be hard coding your degree of parallelism, but it's not the majority, nowhere near the majority, right? So that's the basic idea behind Spark. So already you've seen it. This is Azure Databricks, a workspace here. We're going to circle back here and explain more about this as the session progresses. But already you've seen a little bit of Python code. Did that look that hard? I mean, you could have written this code, right? It's not that tough. Okay. So if we go back to what is Spark, the idea is that if we want to do streaming applications, advanced analytics, and machine learning applications, deep learning applications, or we want to just do some ETL processes, we can build that inside Spark. And the strength here is that Spark will scale as your data and workload scales without having major code changes. That's the idea. So Spark makes it easy to work with these data sources by implementing structured APIs and low-level APIs. And the main low-level API that we use is an RDD, and the main structured API we use is a data frame. Don't worry about that right now, because we'll explain that in just a second. Now, I should tell you that I've got a lot of slides, by the way, and we're going to go through them really quickly because I'd rather show you code than slides. So I already uploaded the slides to my blog and it's SlideShare. So if you go to my blog right now, which is just blog.ikeellis.com, you can download these slides right now. There's 59 slides. I'm not going to read all these slides to you. And I just want to have you have that information as a reference if you want to circle back at the end of this session and read more thoroughly about it, okay? But the type of applications that use Spark and Azure Databricks are like ETL applications, predictive analytics and machine learning, some SQL queries and visualizations, and then a bunch of other things, but it's all revolving around data analytics and data preparation and building data pipelines. That's why we use Spark. We don't use Spark as like the engine for an OLTP application. Because Spark isn't really good at updating data one record at a time. It's really good if you're trying to read off of an IoT stream and then you're trying to alert when something bad happens with IoT, like let's say we want to know when a car breaks down or an engine fails or a sensor malfunctions. Spark can do a really good job reading and reacting to data, but it doesn't do a good job updating data. Like we would never use it to replace, a database that Walmart would use for their website or something like that. So if you want to interact with Spark, you can interact using a lot of different languages because the APIs get implemented at a low level, and then these language APIs are released on top of it. So Spark is written in Scala. So all the APIs that Spark releases are all released in Scala. Now, Spark has this idea of having a first-class citizen. So the three languages that are first-class citizens for Spark are Scala, Python, and SQL. And a secondary application is Java. And the reason for Java is because Scala is basically a functional implementation of Java written in Java. And so because we have Scala as a side effect, we also get Java. But Java is not super popular to use in Spark. The three most popular languages are Scala, Python, and SQL. Those are first-class citizens. And what that means is that Spark will not release a feature without releasing an implementation method of that feature in Scala, Python, and SQL. So if you want to stay with Python, you love Python, and you want to implement all your applications in Python, you can absolutely do that. And as Spark releases, you're guaranteed to get all the new features at the time of release, which is really great. Microsoft released a C# wrapper for Spark. So if you want to write in C#, but you want to write in Spark, you can do that if you'd like. And then we, there we go. Okay, so let's do a brief kind of history lesson. So real quick, let's go back to Paint because I feel like maybe Paint would be a better option. Hopefully you guys can see my screen and this thing's big enough. But let's say that you had a hard disk. This is your hard disk and HD, right? Okay, and if you had a file that you wanted to save on your hard disk, every single disk system has a directory entry table. So usually, they call that a det, right? What the directory entry table does is it basically says, if you have like C:\temp / customers.csv, right? That directory entry table says, hey, when I saved your file, part of your file was saved here, and part of it was saved over here, and part of it was saved over here, right? So your file on the hard disk could be fragmented in 3 different places, and the directory entry table is basically pointing where that file is on the hard disk, right? Well, once you understand that, it's really easy to understand what happens if you have multiple servers. So what happens if you have like server 1 here, server 1, and let's just copy that real quick. Um, So let's say you have server 1 and you have like server 2 and you have like server 3, right? And then all of these guys have a hard disk attached to them, right? Hard disk attached to them, right? Okay. What happens if you have a file over here that this is your customers.csv file that you had before? What happens if that file is like 100 terabytes or like 500 terabytes, right? That file is now too large to store on a single hard disk or even a single server. And so what happens with distributed file systems is they take this really large, 100, 1,000 gig file or whatever it is, and they divide it up and they say, part of your file is going to be stored on this server, and part of your file is going to be stored on this server, and part of your file is going to be stored on that server. Well, guess what? What lies between there is what's called the name node. And that name node is basically a directory entry table. And it says, okay, this customers.csv, this is the thing that is telling you part of it is this server, and part of it is this server, and part of it is this server over here. So if you're a user and you say, hey, I need part of customers.csv, the name node knows which part is stored on which server. And if you say, I need the middle part, or I need the whole thing, or whatever, it goes and finds the part you need, grabs it off of that server, and then it responds it back to the customer. Hey, this is the part you need. Here, coming back. Okay, so this is called a distributed file system because the file's too large for one server, so we distribute it across multiple servers. And now you know what HDFS is, because that is Hadoop distributed file system, right? HDFS. So if that is the way that we grab a large file and we move it across multiple servers in HDFS, what do we do if we want to share CPU? So let me open up Paint again real quick. So imagine that you have the same servers that we had before, right? So we have like server 1, right? There we go. Okay. And now let's say that we have, same thing, right? We have 3 servers. Sorry about the 1. I keep messing that up. Okay. And now let's say that we want to use multiple CPUs. All these servers have a CPU, right? And so what happens if we want to use the CPU on different servers? Boo, boo, boo. So what that would imply is that we have a great big script here with a whole bunch of code, just lines of code coming across, right? And we want to run that code across multiple servers. We want the code to execute, and then we want the code to come back to us, right? So this is similar to the C# example, except we have an automated way of doing it. And what it does is it just says, hey, run this thing on different servers and get different results, right? Get the results back and then hand the results back to me, right? This is what's called resource negotiation. And this is the main feature of Hadoop. So Hadoop allows for code to get executed on multiple servers, and then that results of that code to be handed back. And the mapping of the code to the right server, and then taking the results back and compiling the results and handing it back to the user is what's effectively called map reduce, right? So this resource negotiation is a way of sharing CPUs. And there's been a problem with Hadoop for the last decade that people have complained about for a long time. And that is Hadoop, when it runs code, it tends to like to write the intermediary results of all the code onto the disk again. So it's very disk oriented. It persists everything to the disk over and over and over again. And so typically that means that when you run Hadoop jobs, they're not very interactive and they take a really long time. So now that you know about HDFS and now that you know about Hadoop, let's get to Spark. So what happens in Spark is the same thing, except now instead of CPU, what we do in Spark, so here's a server, here's server, right, here's server. And the idea behind Spark is that we have RAM, we have memory that we want to share, right? Okay, so if we select that, so each one of these servers has memory, and we don't want to write our intermediary steps out to disk anymore. So if you look at kind of the paint progression here, if HDFS is shared disks, and if resource negotiation in Hadoop is shared CPU, what Spark is shared memory without over relying on writing intermediary steps to disk over and over again. So the idea is that server 1 memory and server 2 memory and server 3 memory, this is just all one great big block of memory here that's usable for everyone. And so if I'm a user and I have a request and I say, hey, please load a bunch of data, put it in memory, and then add some columns or change some data types or concatenate these columns together or do some math or do some machine learning, that memory is functionally operating as one block of memory. It's staying in memory, and the work is getting done a lot faster. So if you hear about performance differences between Hadoop and Spark, they will say a lot of numbers. You know, hey, it's 3 times faster, or it's 1,000 times faster, or it's some increment faster. Now, I'm not here to tell you what increment is faster, mostly because Hadoop and Spark are changing all the time, and Hadoop is, fixing some of its shortcomings. But the idea is that Spark keeps data in memory for longer, that it is an increment faster than other MPP systems, and that it makes using shared memory easy for the developer, right? So if we go back to my example that we looked at before, right, which, this really simple, hey, read the CSV and then show the data, right? What we're really talking about is you don't know if the memory it took to display this for us is on 1 node or 8 nodes. It's the shared memory that is showing this to you so quickly, which is why the first example of this demo was frustrating, because typically Spark is much, much faster because of the shared memory aspect. Now, that shared memory aspect allows a data scientist or a data engineer or a data professional to interact with the data very interactively. So that means that if I've got a lot of data sitting in HDFS or Azure Blob Storage or Azure Data Lake Store or a SQL Server or a SQL Data Warehouse, if I've got a ton of data and I want to bring it into Spark and I want to explore it, I can explore it much more interactively in Spark across multiple nodes because of the shared memory than I could if I were using Hadoop or some other MPP tool like Redshift or Azure SQL Data Warehouse even, right? So I know that this is hard because you guys are not connected to me, so I can't see the look on your faces, but hopefully that makes Spark make a little more sense, like what the design idea behind Spark was, and you feel like maybe Spark was a little more accessible to you, okay? So let's go back to the slides. Okay, so we talked about HDFS, we talked about resource negotiation, we talked about shared memory. Okay, Spark can read data in or out of any of these data sources that you'd like. So you can see a lot of Azure stuff there, but the messaging systems could also be Azure Event Hub too. And Azure Blob Storage, Data Lake Store, SQL Server. Cosmos is a huge data source for Spark jobs and Azure Databricks. Okay, Spark application architecture. I don't want to bore you with a lot of this, but the idea is this. If you're a client and you have an application, you submit that application to a Spark cluster. The Spark cluster creates a driver for you, and that driver is the main way that you're interacting with Spark for the life cycle of your application. So as long as your application is running and using memory, that driver is consistent and managing everything. The minute your application shuts down, the driver shuts down. Okay, so in a Spark cluster, you will have a cluster manager and at least one worker and multiple workers that will always be running. And a worker is just dedicated CPU and memory for the cluster. Now, in your mind, you might be thinking of the workers as different servers, and they could be in a Spark cluster, but they don't have to be. So all of these components can run on one machine if that's what you need. And the reason why I'm telling you this is if you want to play with Spark, you don't have to you know, build 5 nodes, 5 different machines and then start playing with Spark. It's way, way easier to play with Spark than that. And so you can experiment with the MPP aspect of Spark by having multiple workers, but these are all can be on one machine if you'd like. And it's because each of these workers are in their own JVM. Remember, I told you that Spark was written in Scala. Scala is over Java. Java is executed on the JVM. This worker's on a JVM. This worker's on a JVM. You could have 10 other workers here all on JVMs, right? And each worker is just dedicated CPU and memory. So when the driver gets your application, it asks the cluster manager for resources. And the cluster manager says, okay, let's start collecting resources across multiple workers for your app. And so it goes to this worker and it says, hey, I'm going to need some CPU and memory for this application the driver is saying it's going to run. And the executor says, okay, boom, I'm in memory. And this executor says, boom, I'm in memory. And 3 more, boom, I'm in memory. And now those are all shared across those workers. And now as the driver starts issuing commands, these guys start running and handing data back to the driver, and then the driver collects the data and hands it back to you. And that's basically what's happening inside the Spark application. Now, I've got a bunch of slides that talk about that in detail, and you can look at those at your leisure, but I'm going to move on from that and not cover everything that's in all of the slides. A couple of things though, the Spark driver creates a DAG. See this DAG? That DAG is, it's very similar. Actually, let's look at the DAG here. So this directed acrylic graph, it's very similar to something you know and love, which is the SQL optimizer. So all of you SQL professionals are very used to seeing something like this, right? What is this? This is a physical execution plan, right? And what do we know about the SQL physical execution plan? We know that you write SQL, like select business entity ID from human resources employees, right? You write that code and you submit it to the optimizer, and the optimizer doesn't execute based on what you wrote. So it doesn't care that you had like an inner join or a left outer join or a cross apply or whatever. It doesn't care, right? It looks at your command as a request for data. You're basically saying, hey, I need some data from SQL Server. And the optimizer takes that command and interprets it and creates a physical execution plan that's pretty decoupled from what you asked for, right? You didn't put nested loop join in your SQL statement, right? You didn't say, hey, please scan this index, right? Please seek this index, right? The optimizer came up with that, and then it collected all the data that you needed, and then it handed that data back to you, right? Well, that's what the DAG is in Spark. So Spark, you wrote Python here, or Scala, or whatever you wrote, right? And then when you wrote it, you submitted it to the Spark driver. And the Spark driver looked at what you asked for, and it said, wow, you asked for some things, but I don't have to work as hard as maybe you think I need to work. And so the Spark driver created this DAG, which is basically an execution plan. And it said, okay, I'm going to do a bunch of things. And then when I'm done with all those things, I'm going to hand your data back to you. Now, in order for the DAG to work, it uses something called lazy evaluation. And this really throws off new Spark developers if they've never seen this before. So what can happen, and just kind of for fun, I'm going to show you here. I'll explain this in just a second. I know I keep going back into the notebooks here, so don't really worry about it. But what I'm going to do is I'm just going to show you like some complicated lines of code that we haven't really talked about, right? So this is like a query, right? Like this might scare you, right? And then something's going to run, and we might say like, you know, dot min or something like that, right? And then we're going to show the results, okay? So to a SQL author, this looks like 3 separate lines of code, right? But to a Spark author, they realize that I might be doing 100 things here, but until I actually request data, Spark is not going to run anything. So I could have 5, 10, 15 lines here that are all describing what I want on separate executable lines, but nothing actually gets compiled and executed until an action happens at the very end. And so when you look at this, you are saying, oh my gosh, there's no where clause. They're asking for all the columns. Oh my gosh, these guys are crazy, right? But a Spark author might not worry too much about that because in later lines, they might be narrowing what they're asking for later and then finally getting it at the very end, okay? So that's very different than any other language that you've probably used before. And that feature is called lazy evaluation. I'm going to delete that now and then go back to the slides. Okay. So Spark delays the execution until an action is called, like collect or show or write or something like that, right? And then this allows Spark to delay the creation execution of the DAG until it sees how the code's being used. So if we see a max or a count, the driver's going to say, I don't need to do all that work to get a count. I can just push that down to whatever resource you're asking this for. Let's say you're asking it for SQL Server or Oracle or Azure Blob Storage. I'm just going to push it down, or HDFS, and then I'm going to get the results from that node, and then I'm going to hand that back to the user. So all statements before the action are just parsed and not executed until Spark sees an action. So inside Spark, every single line of code is divided into either a transformation or an action. So it's transformations that get delayed, and then actions actually make things work, okay? All right, so we don't need to go through all of these things, but let's talk about Azure Databricks. So far, I've been talking a lot about what Spark is and how Spark works, but let's just real briefly talk about what Databricks gives you. So Spark can be difficult to set up on its own, and getting the node count right in a cluster can be very difficult. And if you get it wrong, it's a lot of configuration to change it and get it right. There's a lot of prerequisites, like you have to have the right version of Java installed, and the JVM has to be running. And if you're running over Hadoop, you need to have Yarn implemented. And there's a lot of decisions that need to be made regarding scheduling and storage and where files are going to be and all that stuff. So if you're doing that on premise, Spark, there's a lot of work to be done before you can begin to write code. Azure Databricks solves a lot of that for you. So I'm going to go into, where are you? There we go. Okay. A lot of you are familiar with this. This is the Azure portal, right? So this is just my Azure portal dashboard, right? And if I want to begin using Spark with Azure Databricks, I just click the plus symbol here, and then I just type in Databricks, and it says, hey, do you want to run Azure Databricks? And I click yes, and I click create. Hey, okay, so let's name it. We'll just call this HOP24 demo. Oh, nope. Okay, demo. Okay, and we'll check this subscription, and we'll do it in my like tear down, delete this resource group, right? And then I choose the location, and I do a pricing tier, and for us, we'll just do a trial, right? And then it says, okay, deploy it in your virtual network, no, and I click create. Okay, it's creating a workspace for me right now. Did you see one question about how many nodes in your cluster? Um, how much money do you want to spend? Did I make any difficult decision there? I didn't. It is building a Databricks workspace where I can immediately begin writing code in Spark right off the bat without worrying about an IDE. Am I going to write my Python applications in PyCharm or Visual Studio Code, right? Or Sublime Text or whatever, right? I didn't make any of those decisions. I just said, bring up Databricks for me. Now, this might take a little bit. Sometimes it takes, a few minutes to do that. So we're just going to go to my workspace here. And when you create it, this is what comes up. And if you say launch workspace, it signs you in using Azure Active Directory. That is amazing. That means that I can give permission to this using AAD. That's a great benefit, right? And now I can immediately begin writing Spark stuff. And the way I do that is if I click on Workspace and I go find my workspace and I say create a new notebook, and we'll explain that in a second. And we'll just call that the HOP24 demo notebook. It's going to be in Python. And I click create. Okay. I can now begin writing code in this notebook, which is awesome. So you saw earlier how I was just typing stuff in a cell, right? Like for instance, if I said, let's go do that read the CSV into a flights data frame and execute it and run it, boom, it's running. Okay, now this Azure Databricks workspace is super cheap. Like I don't really remember the price, but the workspace itself is like $10 or $20 a month. So your users can begin running Databricks and Spark just this quickly. It doesn't take very long to get up and running and playing around with it. Okay. Now, where you spend money is on this tab over here. This is the cluster tab. And I already made this Ike Demo 1 cluster because I didn't want you guys to have to wait. But if you wanted to create a cluster, you just create the cluster. We can say HOP Demo 2, right? Pick your cluster mode, which is beyond the scope of what we're doing here, but just keep it on standard for now. And then where you spend money is this part right here. So the cluster can be an auto scale cluster with 2 minimum nodes and up to 8 nodes. And each one of those nodes will use 14 gigs of memory, 4 cores, okay? Or you can ramp that up if you want, right? You can make this like 140 gigs of memory, 20 cores, right? You can really ramp this up. But what you're doing is you're basically following VM pricing. You are spending money, right? So just be very wary of this. So maybe if you're just playing around and you don't want to spend a lot of money, clear enable auto scaling and drop your workers down to 1. Now, 14 gigs of memory, 4 cores, you're spending, $30 a month or something on a cluster, right? But if you want to play around with partitioning and scaling out and scaling horizontally and having a lot of nodes and a lot more memory, then obviously you can ramp this up and, you'll spend the money, but, it's available to you just like that, right? So if I click create cluster here, it takes between 5 and 7 minutes to create that cluster. And you can kind of see if I refresh this page, come on. It's going to come up in a second, but there it is. Okay, HOP demo 2. It takes between 5 and 7 minutes to bring that thing up, right? Now I'm not going to wait for that, but I just wanted you to see how easy it was, right? You could create 5 or 10 or 15 clusters here if you wanted. And here's the great thing about it. If it's not running code, after about a couple hours, it spins it all down. So you're not, this Ike Demo 1 cluster that I made before the demo started, I could forget to shut that down. And by 8 p.m., 9 p.m. tonight, it's going to spin all this off and turn it all down, okay? Okay, now if I want to run some code, I just go back to my workspace. What did I have? Let's see, users, Ike. What we were already in my demo 1 code, right? So if I go to, I thought I called it like HOP demo, didn't I? Uh-oh. There it is. Okay, so you go back to my demo. Okay, let's get into the code because I think the code is super fun. All right, so you just saw me bring some flight data. Let's break this down just a little bit. Spark is my way of getting to my Spark context. This is my way of asking the Spark cluster to do work for me. And I'm saying, hey, Spark, read a CSV and go get that data from WASB. What is that? That is Windows Azure Blob Storage. That's what WASB is. This is a web HDFS driver that's written over blob storage or Azure Data Lake Store. And then I say, go into my Azure blob storage account and go into this container, this blob container, and then go find a CSV called flights.small, and that file has a header. So read the header and then show me the results of it. And it did that. Okay. So if I wanted to do something in another line of code, I just hit this plus symbol down here. And for instance, I can say, hey, take the flight hour and minute and break it down to minutes, total minutes, right? So multiply the hour by 60 and then plus the minutes. And then give me a new column called duration in minutes and save that in the same data frame that we used before called flights, and then show me that. And the shortcut to execute this is Shift Enter. So I'm going to run that key right now. It runs it, and there's duration in minutes. You can see 6 hours, 58 minutes is 418 minutes, right? 10 hours, 40 minutes is 640 minutes, right? So this is something very common to do in ETL, right? We're just adding a new column here by taking some data and adding them together, right? You guys can do this. Okay, no problem, right? You could write this code, right? Okay, if I have a new cell for code here, I can say, create a view for me. It's just a temporary view. Call it flights and put that into a metadata repository. This is schema on read. So I'm basically building a schema here on read. And now if I show you all the tables that I have in my, my workspace, you can see I've got a whole bunch of tables here, right? But I also have this flights table, and it's temporary. So that little view that I have is now in my little metadata repository available for me to use. And what does that let me do? Well, it lets me run SQL against it. Like, hey, give me top 10 flights here. So this is just a SQL string that I'm putting in the query variable. And then I'm running that query variable, spark.sql, right? Spark is me telling Spark to do something. Hey, run some SQL for me, run this query, and put it into a new data frame called flights 10, and just show me that. Show me the flights 10. So I run that, and those 10 flights there. Pretty easy, right? Okay, so now here's something that is comfortable to SQL developers. You can ask Spark, give me an explain plan. So if I run that, it'll says, oh, you've asked me for a bunch of things, and I'm gonna do an in-memory file index, and I'm gonna do a filter, and I'm gonna do some other things, right? So you can go look at your explain plan, and Spark won't execute the action. Spark is saying, if you wanted me to execute this, this is what I would do to execute it, right? Very similar to like, hey, get me an estimated query plan here, right? So if I go into some of these jobs and I open them up, and what am I looking at? If I say view this, what is that? That's the DAG, right? So I say, here's the DAG and here's my schema that it's going to pull back for me. So that's kind of cool that, if you wanted to see the physical execution plan, the DAG that we talked about earlier, you can do that right within this little notebook environment. You're writing code and you're working and you're seeing what Spark is telling you exactly what it's going to be doing, right? So I can filter it down even further. I can say, hey, go to that flights data frame and give me every flight over 1,000 miles, right? There's actually two ways to do that. You can filter it using a string like this, or if you wanted to reference flights again, you don't need the string and you can reference it, your preference on which code is easier to read. But they both do the exact same thing, and they both bring the exact same results back to you. So you'll find that a lot in Databricks, that there's a lot of different ways to do the exact same thing all the time. So for instance, if you want to run a select, like, hey, I only want tail number, origin, and destination, you can do it through a select and string, or you can do a select and flights.origin, flights.destination, flights.carrier, right? Same idea. Or there's also, you could have multiple filters. So look at filter A. give me everything where flight's origin is Seattle, and give me everything where the destination is PDX. And then here is an action. You're saying, hey, filter both filter A and filter B, and then finally just show it, right? So it could be just selected to.show. That's the action, pardon me. This one right here at the very end is the action. So when I shift enter that, these are only flights from Seattle, right, to PDX. So a SQL developer might look at this and say, man, that's crazy. Why are they doing all this so broadly? But really the real show, the real action isn't happening till line 15. And we're combining it all on line 14. And really only this is being executed, right? This other stuff, it's just us directing Spark what we want in the future, right? Those are transformations. Does that make sense? Does that feel comfortable? I hope that feels a lot more comfortable, right? So we could do all kinds of stuff. This is very common to do in ETL. Hey, give me an average speed. You know, take the airtime and divide it by 60 and call that column average speed. That's one way to do it, right? Or this is the column is called average speed. And then this is a data frame where I'm saying select, just like a select statement, give me origin, destination, tail number, and this new column I just made. That's one way. This is the speed one data frame. A second way to do it is you can just embed it right there and say, hey, select expression, give me origin, destination, tail number, and then hey, this is the distance, this is the average speed, distance divided by airtime divided by 60 is the average speed, right? And you can see that if I create these two data frames, they're created, I could just say, hey, speed1.show, shift enter, there, boom, right? Or if we just change that to speed2.show, hey, don't do that. I'll go speed2.show, same data, right? So these data frames are essentially the same. Oh, I just moved down a little bit, sorry. Same data. So even though the code looks different, we're getting the same results, right? So you'll see that a lot in Spark, that there's always several different ways to do the exact same thing, right? And if I say, okay, to show me what's in that data frame, speed2.count. Oh, there's 10,000 records in there, right? If I say, show me what's, show me the schema. Let's see. There, here's the schema of that data frame, right? And if I wanted to like change a data type, let's go back to the flights. So this is the flights data frame, and I do with column. Hey, distance numeric is the new column. Take the distance column that I already have and just cast it as integer. So this might have been like a string before, and I'm making it integer now. And so when I run that, it gives me a new version of the flights data frame with the new column, right? So if I said flights.show, right, you can see distance numeric, right? This might be a string. Now this is an integer, right? That's how you would do a cast for later use. So very common to do an ETL, right? And you guys are doing it so easy, right? You could learn this code. Python's not that hard, right? You can get in there, roll your sleeves up and start messing around with it. Here is me filtering flights where the origin's PDX and I want the minimum distance that you see. And where the origin is Seattle, give me the maximum distance that you see. And so when I run that, it says your minimum distance for Portland is 106 and your maximum distance for Seattle is 2724, right? In fact, if I just wanted, to list those, right, we could go down here and we could see all the distances and we could find that 2724. Unfortunately, it's not easily viewable. But I wonder, so this one's 2677. That's pretty large. H&L airport code. What's the H&L airport code? Honolulu. Does that sound right? So if we go back to our demo, does it seem like Seattle to Honolulu is 2,677 miles? I bet that's pretty close, right? Okay. All right. So I can say like, hey, let's do just like a quick map reduce, like the very typical, show me the flights, group by my flights that are by tail number, call that by_plane, and then show me all their counts. And when I run that, you can see by tail number, this N442AS has 38 flights, right? This one has 2, this one has 45, right? So again, the group I did, this was a transformation, and then the count was a transformation, and the show was the action. And that's when we really started to see stuff. So we could see that, in the DAG. The DAG will kind of tell us what stages it needed to complete to get that work done for us, right? Okay. So are you guys getting more comfortable with this? Is this looking like it's too hard? No, you guys can do this, right? I can bring in other Python or PySpark packages here, like I'm bringing other functions here, and I can, maybe do some ag. Like this is standard deviation. Hey, here's an aggregate for a standard deviation for departure delays, right? So I can run that, and uh-oh, why are you squawking at me? Because it's looking for a column that doesn't have yet. So I can add that column real quick, then run this. There we go. And here's telling me any flights that might have had a bad delay outliers, right? Okay, and then let's take a look at some of this code. What am I doing here? Hey, go get me airports. So that's new, a new file, a new CSV, right? Airports.csv. Header is true. Okay, we can show those airports. Then we're going to rename the column. Take the FAA column and change it to DEST. Why? Because we want to join it with flights. So I'm going to create a new data frame called flights with airports in that shared memory. And then I'm going to join 2 data frames together on destination, a left outer join, and I'm just going to show it. These are all the flights that have corresponding airports in my record set, in my data. So when I run that, happens real quick, and boom, there they are coming out. Great, isn't it? Okay, so that's a join. That's how easy a join is, right? Okay, let's see. I'm actually going to get rid of this show because those are just the airport showing. I want to see that other one. There it is. These are actually, this is the flights with airports. I was not seeing it because the airport show was coming up too quick. Okay, there we go. All right. So we can do joins. That's cool. And if we want to write, a write looks like this. So flights with airports.write.mode, there's a lot of ways to write. I could write this as a CSV. I could write this into Azure SQL database. I could write it in Cosmos DB. I could write it wherever I wanted to write it. But let's say I did all my ETL and now I'm all ready to rock and roll, and I shift enter, and now I have written a table locally called flights with airports. And now that data is always available to me. And so if I want to run a query and select and get all the data back out the same way we've been doing it, the previous times, I just run that, and then I can show this new one so you can see it. And now it's running. Now, this thing, this notebook I have where I just think it's a Rembrandt. I just think this thing's so beautiful and I want to run it all the time. If I want to make a job of Hop 24 demo, I can just schedule it. And I just say, just like a SQL Server job agent, right? Hey, run this thing every hour starting at 5 o'clock. Click OK, boom, it's going to create a job. And if I open up my jobs down here, you'll see jobs that you can run, and you can see their status and how they executed and how fast they are and all that stuff right here super easily. So remember, I said our goal was that you felt like this was no big thing and that you get started with it. And I hope you found this fulfilling, that you think that it actually achieved that goal. So do we have any questions, Rez?
So far, no questions.
All right. Well, it seems like people stuck around to the end, so that's good. Yeah, if there are no questions, that I had the last 6 minutes available for questions, but.
I just got a comment from someone. They said, very neat and crisp explanation. Thanks, Ike.
Good, good, I'm glad. Yeah, you're welcome. I don't know if like people are typing or if we're all wrapped up. But look, while we're doing that, what I'll do is I'll just come back to the slides and put you on the last slide that I have. I know I skipped a whole bunch of slides that you can go back and look at, um, some another time. But what I'll do is I'll bring up my contact information at the very end. Uh-oh. Do. There we go. There's my contact information. You can email me or tweet me or follow me on Twitter. I make YouTube videos. I have a blog post on the Power Apps blog that just released today, and I'm doing a webinar for the Microsoft Power Apps team on Thursday. And that Power Apps blog that I wrote is how to combine Azure SQL data, Power Apps, and Power BI to create an updatable dashboard so that people can update data and see those results immediately on a dashboard, which a lot of people ask how to do that. And it's easy to do as long as you're using those 3 products. See that on my Twitter if you want to link to that. And then I'm speaking at SQL Saturday San Diego, and then I'm speaking, of course, at PASS Summit. So a lot of ways to interact with me if you'd like.
So
Okay, are
yeah,
we all done?
no questions so far. So I guess we can wrap up this session. Um, Stay tuned for our next session, evaluating cloud products for data warehousing with Ginger Grant. Thank you all for attending. Thanks, Ike. I really appreciate your time. It was a very informative session.
Yeah, thank you. I'm glad you guys liked it. Well, and I hope I'll see you guys next time.
Thank you.